Okay, I guess we're all good. So welcome to this course on intermediate Git and GitHub. My name's Joe Wallwork. I'm one of the RSCs in ICCS. This is Tom Meltzer, also one of the RSCs. So these slides are available online. Sadly, it's quite a long URL, so I should have probably got a shorter one. But if you join the Slack workspace, there's a channel for this workshop. I think it's called, WB1 Intermediate Git and GitHub. So if you join that, all these links will be on there as well. I can see there's only currently 3 people in the channel. So if you go on there, then we'll try and moderate that channel, but you'll probably get a quicker response if you just put your hand up. So there's links to these slides that are online, and then there's links to the repository, which has just got some examples in there. There's going to be some exercises and some demos. It's kind of a bit of a mix as we go through, but we'll just work through the slides and then there'll be time to sort of work on some of the exercises. We're going to cover 4 main things. So branching and conflicts. So the beginner's course goes about as far as the idea of branching, but we're going to go into that in a little bit more detail, discuss when to use branches, how to use them, and how to address conflicts. We're then going to look at some of the more intermediate commands that weren't covered in the beginner's course. So for example, like rebase or git stash. And then we're going to move on more into the GitHub side and have some information about different things that you can use to build effective software engineering workflows with GitHub. So project boards, continuous integration testing, stuff like that. And then there's a section at the end which we don't anticipate being able to cover very much of because we probably won't have time. But if you go there, there's a load of tips and tricks, essentially some fun stuff, depending on your opinion. And if we have time, Tom will do a demo, but it might take too much time, so we'll see where we get to. So yeah, if you could just navigate to this repository and have a quick read through the README. The repository does involve Python, but we're not expecting that you understand Python. It's just a bit of example code that we'll use to demonstrate some branching and conflicts. Feel free to create a fork of the repository. And if you could clone it as well, you'd be able to follow along with the exercises. So we'll leave a couple minutes for that. If you have a problem, just put your hand up. But given it's the intermediate course, we don't anticipate too many problems. One thing we can do while we're waiting on that is, distribute these power sockets. Is anyone in desperate need of a power socket?
We're going to try and chain some. Yeah. Matt, if you give me one more, I'll chain 2. That's maybe enough on the limit.
The one over here is also a really long one if we want to switch it around. Fun.
That is a good point. Okay, and then I'll put these 2 near the front. So you guys take this one. And give me a second and I'll come back. That's a start. Okay. It's like when I was a kid, they told me not to do this sort of thing. It's like fire hazard level 1. Is that on for you? I'll whack this up here and you can share.
There you go. Thank you.
Thank you so much.
You need one? Okay. Yes, lecture's being recorded. Yeah, so if anyone is concerned that both the beginner and this lecture are both being recorded, so if you felt like you were in between and you were like, oh, I don't need the beginner one, but maybe I'm somewhere in between, then you can watch both recordings after. You want to? Yeah.
So just while we're doing that, I'll just do a very quick demo of what it should look like. So we've got this link here to the repository. I guess that's fine. Yeah, so I'm guessing that might be a bit small.
Oh, I'll do it. I'll make it bigger if you want.
Yeah. Thanks.
Is that okay?
Can people read that okay at the back? Or enough to see that it's GitHub, I guess? Yeah, so this should take you to this repository within the Cambridge ICCS organization, Intermediate Git ICCS Summer School 2024. So you can fork that. I can see that quite a few people have already forked it, which is great. It's quite a small repository really, but we're going to use it to demonstrate a few concepts. So there's the assumed knowledge, which we've already mentioned. There's a link to the slides. As I said, there's some simple example code that is written in Python. It just is about determining the equation of a line from 2 points and a test that goes with it. So if you want to run that test, then you will have to install a couple of things potentially. So there's some instructions below for how to set up your Python environment, but it's not compulsory, to be honest. But if you want to be able to run the test, then you should do that. In the interest of time, I will continue with the slides, I think. So, yeah, if anyone has a problem, I recommend putting up your hand, but if you post in the Slack, then we might see it. Or maybe someone will see it. So we'll start off, it's more of a bit of a lecture at the start, so we're going to talk a bit about branching and branch conflicts. So the repository that we've got here has got main. Since this is the intermediate course, I'm sure everyone has seen main before. It's like the sort of the branch which we're going to be having as the, where the software lives, basically. But in this repository, we've got branch protection for main, which means you can't just push directly to the main branch. And we'll talk a bit about branch protection later, but what this means is that in order to contribute to main, you need to open a pull request. So you can see here, the main branch is at the top, and then we create a branch off of it that's just called my branch, and there's a few changes. And then in order to get those back in, we open a pull request. And you should all be familiar with this because we said that that's one of the prerequisites. There's just a quick shortcut there. If you want to create a new branch and switch to it, you can do it in one command using that. What about if you are making some developments and then either you or someone else spots a bug in what you've been doing? Well, you could, if it was just yourself, maybe you can fix that on the branch. But if it's someone else, typically people don't push to other people's branches. So one option is to then create a branch of a branch and then open a pull request to merge that in. So this is something that you might consider doing if, for example, my branch is like a really big change and your branch is just a small fix. So that's one option. And then it starts to get complicated when we look at real sort of Git workflows for major projects, such as the ones within Vesri. So it's very common to have a develop branch. So the idea here is that main is like a stable release that users maybe download. And you can see at the top there, we've got main branch and there's a release that's marked with a star. The develop branch is not necessarily as stable, but it's the place where all of the developers are putting their changes. So you can see there's a lot of stuff going on in this example here. There's different features that are getting merged into the develop branch. There's bug fixes and whatnot. So I'm not going to walk through the whole thing there, but it's just to give a bit of a sample of the kind of thing that's involved with using Git and GitHub in these kind of development workflows. And you can see that eventually the developers put in all their changes and then there's a pull request to merge that into main. So it becomes something that external users will be using. But the thing that we really want to talk about here is merge conflicts. So what happens if you and I both open a branch, we make some changes? If they're on distant parts of the code, that's probably going to be fine. But if we're both editing the same file, for example, or even other things where the codes that we're using interact, we're going to have a problem because we can't merge both of them. So if you merge yours first, you can open your pull request and that's fine. But then when I go to open my pull request, it breaks. And so we've sort of set up here a merge conflict example, which I'm hoping is going to indeed cause a conflict. It definitely did when we practiced it. So there's a few different pull requests that you can have a look at through the links there. So we've got, as I said, there's this function that takes 2 points in Python and it generates the equation of a line. So we've got one pull request here, number 12, which is going to implement equation of a line using a determinant approach. So the current implementation, maybe I should have shown you this before actually. I think this was, if we go to maths.py, you take 2 points, and then it will generate the equation of a line using this y equals mx plus b formula that you learn in school, or at least that's what it's called in the UK. I don't know if people use different notation in other places. But it works, but you have to have this special case, because what if the gradient of the line is infinite? So m is the gradient and c is the intercept. So it's got quite a bit of code to go with it, but that's the current implementation. The first pull request is going to change that to use a neater implementation with a determinant or with Lagrange polynomial. So you can just sort of do it in one line. So you can see here that we've got these different, the 2 points are x0, y0, and x1, y1. So you can use this other approach here. And when we look at the files changed in this pull request, all it's doing is just taking that implementation and then turning it into just a single function there. So it's pretty neat. So I'm pretty sure I opened this pull request and I'm currently viewing it as Tom. So what I'm going to do is I'm going to say, that looks great. Let's approve it. And of course, in practice, you would want to do a bit more than just this.
Yeah,
you can do it if you want.
Yeah, so So there's different options. You can add a comment, you can approve, or you can request changes. Because I'm happy with the code, I'm just going to click approve, and I don't have any changes to do. There you go.
Thank you. So that's been approved by a reviewer, and some people have different practices about who actually merges the thing, but just for the purposes of this demo, we'll have this user merge it. So we've got this merge pull request. There are different options. I guess we can probably cover them here since we're in the intermediate course. So the merge commit will take the head of this branch and the head of main, and it will attempt to put the head of this branch, just those changes directly in. Whereas with some of these other options, with rebase, we'll come to that later. Because we're going to go into rebase in a bit more detail. The squash and merge, it will put together all of the commits from this pull request. So we'll just use the merge commit default option. And you can see that's gone in. And then we'll close that so we don't have 1 million tabs. The second pull request is to check that the 2 points differ. So if you think about this in 2D, we've got 2 points of a line. There's 2 points, a unique line goes straight through it, unless those points are the same, because then there's infinitely many lines you can draw through a single point. So in this pull request, it imports NumPy, and then it checks whether the 2 points A and B match. And if they do match, then we raise an error. So it's again, quite a simple change. Well, there's also a test that gets added, but we don't need to go into that in too much detail. So again, I don't know about you guys, but it seems like a reasonable thing to do. So Tom's just going to put in his review.
That looks good to me.
Yeah.
Thank
you. So again, we can merge that, and that all should go fine, hopefully. Yeah. And if we go back and have a look at the commits in this repository now, you can see that both of them have gone in there. Imp2 was the first branch, and then checkpoints differ was the second one. And then finally, we've got a different approach entirely, so implement SymPy. So I don't know if any of you have encountered SymPy or not before, but it's symbolic Python is what it stands for. And so actually a lot of the stuff we're trying to do here is already implemented, and it's like, why are we trying to reinvent the wheel? So in this branch, bearing in mind that these changes here are compared against what main looked like when this branched off of main. So all three of these pull requests branched off at the same commit from main. This one wants to get rid of all of that code that we had before and use SymPy's approach. So it takes point2d and another point2d, so it wraps the points that you pass within those classes and then uses the line class, which you can get a distance from. So it ends up actually being a bit longer than the implementation that we've changed to, but it might be nice for us to have SymPy do a lot of the testing for this stuff rather than it being on our end. So are you happy with this, Tom? This wasn't actually designed to go quite like this.
Yeah.
But since we've started, we might as well do the third one this way as well. Kind of feels like.
Yeah, and so these aren't, I'd say, proper code reviews. Like, if this isn't a class on how to do code reviews, though. Yep. Not yet, anyway.
Sure. Yeah. Okay. So all three of them have been approved. However, now we've got conflicts, as you can see. So it says here that maths.py is now conflicting with main. So before we can merge this, we need to resolve those conflicts. So there's two options here. Either you check this out locally, and you can do these. Fix these conflicts yourself in the terminal, or you can do it within GitHub using this sort of editor here. So we can see that there's two places where things are broken. One of them is in the imports and one of them is in the code itself. So if we start with the code itself, we've kind of got three different choices here, or at least three different choices. So one of them is that we stick with the SymPy approach, but we get rid of this error checking stuff. So I'm not going to do it here because I feel like I'll make a typo, but you basically just go in here and you can type whatever you want. So like so I would just get rid of this bottom bit and just keep the top bit. Well, in fact, I will do it. So you can see. Oh, sorry, I've done it the wrong way around, haven't I? No, it's fine. It's fine. So you end up with just the SymPy implementation, and then you just want to resolve this conflict at the top as well, so you can see that we don't need NumPy anymore. So you can get rid of that. So that's option one. We're basically just picking one of the branches and going with it. And then if I go back, then option two would be, well, actually, maybe we don't want SymPy anymore. I guess that doesn't really make sense because we've just approved the pull request. But let's say the other option is that you take the other branch entirely of the two that you've been offered here. And then the third way is, well, what about if I want to take the SymPy approach, but I also want to put in the error checking myself? So, for example, you might have some tests that you want to see that it comes up with this exact error message. So you could either leave it like that, or more likely you would probably put that error check first so that it doesn't even do anything until the error check has happened. And then when we look at the imports at the top, you can see that we need both NumPy and SymPy. So again, we're going to take both of these branches at the same time. Does anybody have any questions about any of the stuff that we just went through in that demo? Yes?
So
Okay, so the question, just for the recording, people in the recording, the question was that if you do this on the command line, there's an option for merge own or merge the other. Is there an equivalent on the website? To be honest, I usually do this on the command line, so I don't actually know the answer to that. Does anybody in the room know the answer to that, by any chance? No, sorry. We can look into it and find out for you. But do you have a question as well? Yes? Okay, that's good to know. Yeah,
I was saying we tried not to go like IDE specific because everyone might use different development environments and different languages. So the point was to show kind of a neutral space of where you could resolve these. But I do tend to do all of it in the terminal. Other people like VS Code. Some people like Emacs or whatever.
Yes. The question was whether it's if there's ever any reason to keep a branch after you've merged it. you have any comment?
I have some things. Yeah, get rid of them. Yeah. So basically, we didn't in the demo. You probably noticed, but if we go back to the code, you can see I've got 7 branches. What happens is, so we should be able to see. So you can see this, like, can everyone read that? There's like this color's purple. This one's green. This one's purple. These ones have been merged already, and essentially, like, what happens is, if you don't clean them up yourself, you end up with loads of them, and then they become stale. And basically, you don't want stale branches lingering around on the repository. Also, if you delete them, which I'll show you now, actually. So I'm just going to delete this one, which we've merged, and this one, which we've merged. It is possible to get deleted branches back. If we go back to the pull request, I'm pretty sure. So closed. And we just added this one. And it goes to the 12, isn't it?
Yeah, 12
or 13.
Yeah.
There's normally an option to restore the branch. So it's still available online, but it just stops it clogging up. So I'd say once you've merged it, bin it. Not least because it clogs up and you get stale branches. Realistically, you're probably never going to go back to that branch. The development environment will have moved on, like the main will have moved on. If you want to make, say you had this pull request and you notice, oh, actually, I forgot to add docs, or I didn't update the documentation or update the dependencies, make a new pull request, new branch off of develop, main, wherever you just merged it to, and fix it that way. I've never needed to restore a branch for any reason, so get rid of them, yeah. And not least as well, just one more example reason why you want to get rid of them. I'm in the repo, it's cloned locally. I hope everyone can see this. I'm going to do a git status. If I do git branch, it will show me branches that exist, and I can't remember the syntax, so I think it's branch all, or it might be minus -8. I've got an alias for it, so I've forgotten it. But it also shows you the remotes, and I haven't pulled locally yet, so it doesn't know that I've deleted it offline. But it can be really annoying when you work on a big project with multiple developers. This can easily get to like 300 branches, and then it's just really hard to read out, like, oh, which branch should I be checking out? So get rid of them once you've merged. That's my comments. And I'll put you back.
Yeah, thanks. Good. Yeah, just to complete this demo, since we're here, you can see in the end, we chose both, well, let's say that we decide that we'll take both of these branches. If you do want to do this within the browser, all you got to do is just then, once you've finished fixing the conflicts, go mark as resolved. There may be other files that you might need to do this for as well. And then just commit merge. And I think it will automatically give it some kind of merge commit name. It was already approved. Sometimes on a project, there'll be settings such that if you push after it's been approved, then it will reject the approval. But on this repository, it doesn't. And so we fix the conflict, and we'll wait for these tests to pass, and then we can merge it. So the test suite with GitHub Actions we'll come to later in the course. But you can see that there's a couple of things we can note while we're here, actually. One of them is that, yeah, you can see these ticks next to some of the commits. That just shows that the tests we have set up have passed. So that's one of the conditions for this to be merged. Another thing to note is that you see at the top here in the initial message on GitHub, and I think on GitLab as well, if you put closes or fixes and then a link to the issue, then it will close the corresponding issue automatically when this gets merged. So if we click merge pull request now and delete the branch, you can see it's in purple because it's been merged, and if we click to number 10 there now, that's also been closed automatically. So that's one neat little thing for tidying up branches and issues as you go along. Good, so does anybody have any questions about branching or conflicts before we go on to the next section? Ooh. So we're just going to go through a few different intermediate commands. The first one's not really intermediate. I think they're even covering this in the beginner's course. But I think it's a really powerful tool called git status. So it gives you a lot of information, and I would recommend doing this pretty much all the time, just to check the status of things. So there's quite a lot of information comes up. At the top you can see the branch name is just called my branch, quite unimaginatively. And you can see that it's up to date with the remote branch on origin. And then you can see also that there's been a file that's been deleted. You can see that there's been a file that's been renamed from maths to mathematics. You can see there's a new file. And then in the next section, you can see that there's been some modifications to one of the files. Thanks. And then finally at the bottom, there's some other untracked files. So if you have a file that's lying around and you haven't added it to your repository yet, then that's where you'll see it. So hopefully you're all familiar with that anyway, but we just thought we would mention it. Yeah, I'll pass over to you for Git diff.
Yeah, so I just want to talk a bit about kind of different options for checking the changes you've made, right, when you're working on files. So I get scared touching code that doesn't have version control, or I'd say I won't work on code that doesn't have version control, because sometimes, you open a file, you accidentally hit your keyboard and you're like, wait, what did I just change? And you hope you can Control-Z it and undo it. Git diff is a great way of checking changes in the terminal and seeing, have I changed any of these files that are tracked? But it can sometimes produce output that's, whilst useful, it's not necessarily meant for human consumption. So it can be a bit difficult to read. Like, I appreciate that the font's a bit small. I think I can do this. There we go. But you have like all these pluses, minuses, whether it's code that's been added, whether it's been deleted. It's also not super clear because it's a lot of output, like what exactly changed here? Like, did anything else on this line change, or is it just the indentation? So it's useful. Oh, there we go. But I actually think Git diff tool is a better default to use. So the benefit of Git diff tool is not only do you see the diff, so I'll zoom in on that. I find it's much clearer. So here we can see we added a new comment. Here from this yellow, we can see that we've just deleted the spaces. And then we can just see that we've added a new word in here. And if I go back and compare that with the previous slide, where this was the diff that we had, okay? So the other benefit is we get syntax highlighting. So if you're using editor, like here it shows Vim, but this works equally for VS Code, Emacs, whatever your editor of choice is. And there's also tools called like Meld, which is a diff tool. You can use any of these and you get syntax highlighting, and I think it's just much easier to read. If you want to do this, you can add it to your Git config. So if you're not aware, like typically you have to set basic things in the Git config that's done and covered in the standard class, and that'll be things like you set your email address, your username, and those are the things you do when you first get Git. But you can also set this tool equals, so I've used Vim diff, like I said. If you're using VS Code, Emacs, or Meld, you can just change the tool, and then set prompt equals to false. So if you copy these, the slides are available. You can copy these and put them straight into your Git config, or you can run these commands from the terminal. It's the same thing. It just saves you opening the file and saving it yourself. So here there's a little exercise for you to play around with. If you follow this exercise, so you git switch to example diff. So let's just show what that looks like. So we're going to type git switch example. And if you tab, it should complete to example diff. And then just have a play around using diff and diff tool. It might take you a while to set up diff tool if you've never done it, so it'll be a good chance for you to try getting this done. So we'll just give you like 5 minutes to play around.
Okay, I think we'll go on this unless anyone has any questions, or feel free to, as I said, post things in the Slack as well, and we'll respond, but maybe just a bit later. So we've been talking about how do you check state in Git. Now this is kind of a related thing, and it's about temporary work, or at least the command will be related. So what about if I have some temporary work that I've been doing, like maybe I've got a change that I want to make, and I've just started a bit of work on it, but then I realized, oh wait, I'm on the wrong branch, or oh wait, I need to make some branch manipulations, I need to do something or other that involves changing branches. How how do I just store this temporary work and then come back to it? So one option is to use git diff in addition to git patch. So there's a snippet of code here that you can see. So git diff will just by default, it will either print it to screen or it will put it into your default editor. If you can pipe it out into a patch file, and then this can be used to do some edits. So what you can see here is you can stash the changes by putting them into this patch file, do a git restore, which will just sort of get rid of all of the current changes, but it's okay because you've got them in this patch file. So you then make the required branch manipulations you want to do, and then you can use git apply on the patch file. And what that will do is it will reapply them. And the idea of a patch is kind of predates version control systems. So this existed before people had centralized version control. So it's where developers would be working on a code and they would email these patch files to each other so that they could have updates to the code. So it's a bit of an older way of doing things, but it's one way that you can handle temporary work. There's a couple of comments. One of them is you can reverse a patch by using the $R. So if you can, instead of doing that restore, you could do the reverse patch and it would get rid of all the changes. You could put them all back in. And are there any Subversion users here by any chance? Oh, okay, no. So I don't need to go into this in too much detail. But if there were Subversion users here, they would be happy to know that this is compatible with the patches that you get out of Subversion. So I guess we don't need to talk about that anymore. Yes. Thanks. Okay, there was two questions, well, two comments. One of them was that we will do this for the recording because there might be people that are interested. Another question was, what is Subversion? Okay, it's a different version control system other than Git. It came before Git. And it is still used in a lot of projects. And the main difference, as far as I understand, between Git and Subversion is that, well, there's a couple of them actually. So Subversion it's server-based, and so you always need to have a connection to the internet in order to use it. Whereas with Git, when you can make your commit locally, and then you push it to the cloud or to whatever remote server you're using. Whereas with Subversion, you need to be connected in order to do the commit. And then the other difference is that in Git, the main branch is just any other branch. Like it's just a branch. It's not particularly special. It's just the one that we always go back to. You could change the name. You can have two main branches if you really wanted. Whereas in Subversion, there's this thing called the trunk, which is it is like the main branch, and all branches have to come off of it. And when you have branches of branches, it becomes quite difficult. So those are kind of the two main differences. But Git is increasingly popular, and I know of at least a few places where they're migrating from Subversion to Git. So yeah, it is interoperable to some extent, and we'll probably touch on some more Subversion stuff later. So, as we said, one option for handling temporary work is to use these patch files. But what about if we find all these things called temp.patch everywhere? Yeah, I can admit that that's happened to me in the past, where you've got all these random patch files. You can't really remember what they're for. It seems to be not the greatest way of doing things. Another way is to use git stash. So for those of you that aren't familiar with the concept of a stack, it's where you add things to the stack it's called a push, and then you can pop things off the stack, but only the last thing that was put in. So you can see here that there's in the diagram, there's entry 0 went in first, and then entry 1, and then entry 2. You can only currently access the top one, but you can go back to the other ones if you go through it. So you might be able to think of this as like a stack of pancakes. You can only access the bottom one. You can only access the top one easily. Okay, so if you use git stash, it will put all of your current changes onto the stack. You've effectively had your branch restored, so you can do whatever you want, make your branch manipulations, and then if you use git stash pop, it will put them back in. So it doesn't matter if you're not in exactly the same place that you were before. If the changes are compatible, it will be able to put them back in. So you can see at the bottom there, if you put git stash list, you might see something like this. So you can see the stash entries 0, 1, and 2. and they've got some the names I think just come from the latest commit, if I remember correctly.
It's worth noting the stash is only local to your machine.
Yes.
So in this case, you won't see anything because you've just cloned it fresh. But if you had been making changes, as Joe suggests, you build up this like stack of stashes, and then you can list them this way.
Yes. Okay, so yeah, the question was, what if there's conflicts here? Yeah, with the patch files, you can, I mean, this is kind of a manual way of doing it, but you can break them down into the separate files that they're working on, and you could apply them separately. There's probably an automated way to do that. We are, by the way, arguing here that stash is a slightly better way of doing it than patch, just sort of for the record, although both of them have their use cases. I'm pretty sure if there's a conflict here, it will give you the scenario and you choose.
It creates a merge conflict. Yeah. So it's obviously not the same as merge conflict because you're not merging branches, but basically when you pop it, it will be like, oh, there's a conflict, please resolve the conflict. It looks exactly like a merge conflict. You can just pick what bits you want to keep. Yeah, it's up to you.
Yes, at the front.
Copy of it. So you don't really need to like stash and sort of think about all the complexity of like merging it back and putting away your changes, these things, because you have copies. They ask you questions, help them out, and then still have like.
Okay. So work tree.
So yeah, so we
Thanks.
It's one I've not heard of. So if anyone that didn't hear that, there's this thing called Git work tree. We will add it to the fun stuff at the end. You can go away, read about it in your spare time.
Yeah, thank you. That's a good suggestion.
Without another, does it count an ID, like a common patch? What if I want to add my, say, number 1? Can I do that? Yeah. Okay.
You give it a number, you can see the options, but you can do git pop and then the number, and then it doesn't do the top one, you can do git pop 0, git pop 1, git pop 2. Yeah.
Any other questions? Guess we'll continue. So we're going to talk about Git rebase, which in my personal opinion is probably one of the most powerful tools in Git, which is why we put a little trophy next to it. So there's some common problems here that you might want to address. All of these can be solved with Git rebase. So one of them is, I've made a load of commits, but I decided actually we just want to drop some of them because they were, for example, some temporary commits you put in there so that the testing might work online or something like that. It was just some debugging, some print statements, for example. Another one is that you might want to reword a commit message. So perhaps you put a typo in there or something. You want to go back and change it. The third one is you want to squash some commits in the branch. So I mentioned this before when we were talking about how to merge the pull requests. Squashing will just put some or all of these commits together rather than having lots of individual commits that might sort of do one thing and then reverse it a bit and then do something else. It's kind of meandering. Instead, you just have one change, which can be a lot neater if people are going to go through the commit history. And it can be, yeah. 4 is if you want to change the base of the branch to start at the head of another branch. So I think we put in a diagram for this. Yeah. So this one is a little bit more conceptual. So this is probably the simplest case that you could consider, but this can apply in lots of other scenarios. So let's consider that you've got this main branch and you branch off of it onto my branch and you make a couple of changes. You committed a couple of things. Meanwhile, main has continued. People have been putting their pull requests in. There's some commits you can see on main and it's gone to a new version. So you can see there's this little star there. What happens if you think, oh, actually, I don't want to apply my changes here. I want to apply them at the new version. this is something that Git rebase can do for you. So as you see there, it's taken the same branch history that's in the red box, and it will allow you to move it so that it exists on top of the most recent main rather than on the previous one. You can also do this moving it to other branches, or there's a lot of different possibilities really with Git rebase. So we've got an exercise. This is just the same 4 problems that I just mentioned. If you, locally on your machine, if you check out the branch that's called rebase exercise, so I'm going to do this just to show you what I mean. We're going to check out this branch, and then we're going to do an interactive rebase. Okay. Yeah. Thank you. All right. So this is on the terminal. So we're currently on that branch. If we go git checkout rebase exercise, then
I'm just going to do something. The line's very long, so I'm going to move this folder, my home directory, and it just says, just call it git demo.
Yep.
Because it's harder to read, isn't it, when it's
Yeah, that's fine. Thank you.
Okay, sorry, now continue.
So we're on this branch that's called rebase exercise now. And if we do git log, then you can see I've put in a few different artificial commits here. I was really hoping to put an Easter egg in one of these commits, but I couldn't think of anything good to put in there. So you can see it starts off from this merge pull request. You can see there that's some work that Tom and I did before in preparation. And then, so that's an old version of main. And then you can see there's a few different commits that have been added on top. So you can have a look at what's in them if you really want. But it doesn't really matter too much. What I want you to do is, check out this branch and then do git rebase -i. So that is what does interactive rebase. And then put, for example, let's just put main, because any branch that differs, it will work in this scenario, even if it's just the version of main that you started from. So if you just do git rebase -i and then main, you'll get this sort of this screen that will come up. So you can see the different commits. Confusingly, this git rebase interface and git log order things in the opposite direction. So in git log, you start at the most recent commit and go backwards in time, or well, backwards in commit history at least. Whereas in this one here, it's starting from the first commit that's being applied, and then it's going through to the latest one. So you can see that there's these 5 different commits, and they've got the commit hashes before them, and then before that, it says pick. So what pick means, as you can see if you read all the help text at the bottom, pick means I'm going to start from the new base of the branch, and I'm going to attempt to apply all of the commits that say pick. So okay, that's fine. It's okay. I think I'll probably just leave it as an exercise anyway. But thanks. So yeah, this has been opened in Vim, and so to exit. Hang on, how did it call? There we go.
Custom layout.
There we go. Yeah, there we go. So we exit it with WQ, and that went successfully. You can say successfully rebased. And so what that's done is it's just taken all of the same commits that we had and reapplied them in the same order on top of the later main. So if you do git log, then you can see we've got the same 5 commits, but then it's on top of the more recent main. It isn't the most recent one because I don't think we've pulled what we did after those pull requests, but it doesn't really matter for the purpose of this exercise. But yeah, what I want you to do is do this git rebase -i main and then do what's said here. So you'll need to read some of the helper text below and just go through and try and squash 2 of the commits together, reword the commit message in the 3rd one, and then drop the 4th commit. And if anything's unclear, please just put your hand up.
Yeah, we'll be walking around.
Yeah, so we'll leave like 5 minutes or so for this.
Any general questions before we get started?
So, Okay, so we'll come back to this and I'll walk through this and show you what to do. So a couple of people were a little bit confused about squashing. So with this one, we squash the commit that is getting squashed into another one. So it's a bit confusing the way I've worded it here. The first commit that you see, you leave that as pick. And then the second one, you do squash. So when we exit this...
Come in and undo this. Sorry, this is my custom setup.
If you just exit that, then it should have.
It's really not happy, one sec.
Yeah, that's fine. So it will give you this this display that will pop up, and then we exit, and that's been done. So when we look at git log now, you can see that two of the commits have been squashed together. And then if we go again, then we want to reword this one. So what some people I think tried was actually rewording the thing on the right. That will just get rejected. So instead what you want to do is put R for reword, or type out reword, doesn't really matter which way you do it. And then when you do that, you will come to this commit message editor and you can put whatever you want. In this case, I'll just leave it. Oops. And then finally, for the other one, it's just a matter of just putting a D or typing delete. And that will just drop the commit. And hopefully I set it up so that it doesn't cause a conflict. If that had caused a conflict, we would then have to resolve it in the same way that we discussed earlier. There's a couple of things I've very briefly mentioned, but then we need to sort of move on, really. Someone asked about what's the motivation behind this? Why do we not just merge? I guess it's, so people have different preferences. So some people are quite happy with the commit history having all sorts of random stuff in there, and then it getting merged in. And, you know, that's just, you see that merge committed, but you can still see all this other stuff. Other people prefer to have a much neater commit history so that you can go back and you can check that everything worked at every point in the history. So it is a bit of a preference thing. I would probably advocate towards rebase where possible. Sometimes it can get a bit too complicated when you've got loads and loads of commits, but it does mean that you have a linear commit history. If you have merges, you have this non-linear commit history, things can get really, really complicated really quickly. And there's git bisect, which we're considering doing a demo on, but I don't think we'll have time today. But there'll be a link to it in the slides, and git bisect becomes easier when you've got rebase. Yes.
So, yes.
So the question was, if you rebase on your local branch, what happens if you push back to the origin? It will probably reject it. If you really want to do it, you can put git push -f, which forces. So it will then overwrite. It will overwrite the remote branch with your changes. So sometimes you do want to do that, but you probably don't want to do that if it's main, for example.
So just a note on that, git rebase, maybe not the best name for what it does, because it does rebase, but it also does a lot more. You can kind of think of it as it alters the history as well, because you can change previous commits, you can change the order of them, you can squash them. So you will normally need to do a git force push. So if you've done it deliberately, which you have, you just need to do git push -force, or minus force, or -f. Because you've done it deliberately. Just be aware that anyone else who's working on that branch needs to be informed, because their changes may get overridden or lost. So it's a useful tool. It's like RM. It's powerful, but use it with sensibility, or be careful.
Okay, so we've not got much time left, so we're happy to take more questions in the coffee break after this. So we'll just carry on with the presentation for now. So what happened, people have been trying this out. For some people, it kind of broke things. What happens if you break things in your repository and you're, how do I get back to this stage that I had before that worked, but for some reason I didn't push it to GitHub, for example? Well, git reflog might save your life, because you can, if you type git reflog, you'll see this history of all of the Git operations that you've done locally on your machine since you cloned the repository. So this doesn't exist on GitHub anywhere. On your machine, if you type git reflog, you will see the history of all the, you started on one branch, you checked out a different one, you rebased another one, you did all sorts of different stuff. So I did a Git ref log for the rebase exercise branch we've just been considering, and you can see there's this history there with the different commit hashes and the operations. All of these operations were just commits, so it's not very interesting. And then if you want to go back to one of these earlier references, you would put git reset, and you probably need to use the -- hard option, which I will warn you is potentially destructive because it can get rid of any temporary changes you might have lying around. But if you put git reset -- hard and then the commit hash you want to go back to, you can reverse this process and go back to something that did work. So finally, we'll go on to the last section, which is on software engineering with GitHub. So we've already touched on this a little bit. One of the other things that we find really useful and that we use all the time in ICCS is the idea of a project board. So the example repository has a project board. I was opening it in another tab just to show you what it's all about. So you can create these projects, and whilst they're normally associated with repository or multiple repositories, they live on either the GitHub organization or the GitHub user that they're created for. So it's worth noting that this isn't associated directly with this repository. We just have issues from the repository on the project board. And in theory, you can put any of these different GitHub objects onto it, so issues, pull requests, discussions. But in practice, most people just put issues on because it's a bit simpler. So you can see here that by default, in this particular type of project, there's a few different ones you can choose from. There's a column of issues that are to do, so there's some possible issues we might want to tackle in the future. There's an in progress column, which did have stuff on earlier today, but we've just merged all those, so it's not in there anymore. And then in the final column, it's everything that's been done. So all of the issues that have been finished, and when they get closed, they automatically move into that done column, which sort of speeds things up a little bit. So when you create an issue, you can associate it with a project. So let's click on this one, for example. You can see that it's associated with a project. You see that on the right-hand side there? And I can change the status. So let's say that I've started working on this. I just tick in progress. And when we go back here, we'll see that it's moved. And you can also just drag and drop. So for example, if you're discussing this in a meeting, you can just move it around within the project board there. There's this setting here. You can see that there's a limit of the number of issues in this to-do column. I wouldn't normally recommend doing that. Some people do, but I think in a lot of cases it's not that useful. So you can just remove that, or you can change it to whatever you want. You can also add in other ones. So let's say we want to add in review. That could be quite a useful one to have. You can pick a color, add a description. This issue has a PR under review. You create that, and again, we can move these. Well, I thought we could move these around. Yeah. You can reorder them however you want, and then this is just another column where you can manage your work. Go back to the slides. So as an exercise, you could try setting up a project board for your fork as well. We'll talk a bit about GitHub Actions. So we mentioned earlier about testing. So there was, on the pull requests, there was these little ticks that we needed to have before we merged. So just to quote Wikipedia here, this continuous integration concept is the practice of integrating source code changes frequently and ensuring that the integrated code base is in a workable state. So, you know, this is what Git and GitHub are all about, is that we're frequently making changes. And then CI testing is the part that ensures that the code base is in a workable state. So it means that we're constantly checking that all the tests that we have pass. And if you're interested in seeing how we set this up for the example repository, then just look at pull request number 9, which got a link there. Sorry, it's kind of fast at this point, but we've kind of almost run out of time. Yeah, we have. So we just got a few recommendations as well. So files that you should always include in your repository. A license is really important because it sets out the code, how the code may be interacted with. So for example, can people just freely redistribute it? And there's a lot of different templates that you can choose from in GitHub. So as soon as you create a file with that name, license in capitals, it will open up this set of templates that you can choose from. A README file, so it's in Markdown, where it's got MD at the end. This is the first port of call when you go to the repository, and it tells everyone what it's all about. So it's really important that you have a README in there, even if it's just pointing to where the documentation is. It's important to have that so that people know what to do when they download the code, well, when they access it. And then there's a few settings as well in GitHub. So we mentioned protecting the main branch. So in theory, you can add different rules to any branch, but main's probably the one you care about the most. So there's a setting which allows you to protect it so that people can't push to it, and so that it can only be edited through a pull request. You can have a setting which ensures that tests always pass before you merge the pull request. That's definitely a good idea. Otherwise, you're going to end up with a main branch that's potentially broken. You should require pull request approvals so that people don't just create a pull request and then just merge it because they couldn't wait or something. And then finally, there's an option to disallow bypassing any of those rules or any other rules. So that's probably a good idea. Otherwise, the person running the project might decide that they want to just get something merged. Although, of course, then they can go back and change that setting if they really want. So again, we've got an exercise to do this yourself. I guess I can briefly show you what it looks like. So this will take, you need to change username there, but it will take you to your fork. It will take you to the settings pane, and there's this branch protection rules. So if you click edit, or, well, maybe you won't even have this, because I think when you create a fork, it won't have any branch protection rules. So for us, we would click edit, and we would see all these different options to choose from, whereas for you, it would be add a rule, and you would choose which branch to apply that to. We've got a couple more slides, I think.
Yeah, so what I'm saying, because we don't have enough time to finish everything, has anyone set up CI in this room? Has anyone ever set up CI? Do you use it? Yeah. Has anyone had a problem in CI, and they're like, how do I fix this? Yeah, okay, it's worth you doing it. I'll try and run through it quickly. There is a tool called Teammate. You can see there's a link to it. It's super useful. It opens a terminal connection to a live running instance of the CI. It's the actual one on GitHub. Okay, so it's not it's not a Docker image like it. It's not something that's similar. It's actually connecting to the running container, and you can go in and you can debug an action. So I have an example case. Let's go to our code. So we've got pull request. This one is failing. So it's called debug CI GitHub actions. So it's a test for demonstrating this, and currently it's failing. So I can have a look at the details, and if I go to the details, it tells me something like process exited with error 127, PyTest command not found. Now, maybe I can guess just from this, I might know how to fix it, I can just make the changes to the YAML directly, but I'm going to pretend in this case I don't know what the fix is. So I'm going to show you how we can debug this process live running on GitHub. So basically, we need to add some code to our GitHub YAML file. So for anyone that doesn't know and has never touched these before, if you go to our repo, there's a hidden folder called .github. It's a bit like the .git one, but it's hidden, and inside it there's a workflows test suite. Okay, so this was made by Joe, and it adds some basic testing to our repository. And what I'm going to do is add these two lines at the bottom, so the name and uses, to set up a teammate session. And I'm going to do it just before I have the error. So I've got, here's one I made earlier. So I'm going to do a vim debug.yaml with this thing. So the lines I'm adding are, it's going to be these ones to break it. So let me just do a git diff. So the lines I've just added is we're setting up a teammate session and we're using this code. If you want to see more, please read the documentation. So I'm going to we need to check out the debug CI.
If you want to find out more about the aliases that Tom's using as well, just see the slides at the end.
I'm also using git stash live in the wild because I didn't realize I was on the wrong branch. So here's an example of when to do that. Git stash pop. Yeah, nothing like a live demo. Okay, so basically the thing that was failing on the CI, if I go back to the CI, the thing that was failing is when it got to run tests. So I've added these 2 lines just before run tests. I'm going to save it. I'm going to git add this file, git commit, and I'm going to call it debug CI live. I'm going to do git push. And now I'm going to open a new terminal, and I'll show you why in a second. So if I go back to the pull request that was failed, I've just pushed a new change, and it's going to be running the tests. So I'm going to click details. It's going to start the job. It's going to do all the other setup, but then just before run test, it's going to give me the chance to jump in. So I've got to let it do a bit basic setup. And now it's going to keep printing something to the screen. It's telling me I can SSH. So I can copy this. I'm going to copy this command. And so copy. Oh, and I'm going to paste it. Just the SSH bit. So I've copied that from the internet. I'm going to type it, and it will now put me into GitHub. And if I do. So this also relies on tmux. I don't have time to teach tmux, so I'm sorry, but it's basically I've now entered into this GitHub runner. I could do echo host name, and we should be able to see we're running on this random machine. And the point I wanted to show is if I take the command that was failing, which was the pytest -v, and run it, we should see that sure enough, it doesn't find pytest. So maybe I think, oh, well, maybe the requirements file hasn't been run. So what I'm going to do is I'm going to say, well, maybe I need to try pip installing my requirements file. It's going to install the requirements. This is again live on the GitHub action, like on the actual VM that it spins up. I'm going to install the dependencies because I think maybe that was a problem. Maybe I didn't install them. And now if I run pytest -v again, ah, yeah, it looks like it's working. Super. So now I can make a file, touch, continue. And if I go back to GitHub, actions, this test suite, it's actually passed because when it gets to the bit where it runs the tests, I've already installed the dependencies and now it can work. So then, I haven't finished quite yet, I would then go and change the GitHub workflow, the GitHub YAML, make whatever changes were deemed appropriate. Maybe I sudo apt installed some packages, maybe I fixed a bug in the code. I would then go and make a separate pull request to fix that change. But I can play around interactively and I don't have to keep doing git push, git push, git push, and finding out everything's broken. Thank you for that. And then we need to quickly, I guess, wrap up.
Yeah, we're out of time.
Skip the
so, yeah, we'll leave these for information, which was kind of, we didn't anticipate we'd get there anyway. But yeah, it's a coffee break now. Hope you enjoyed the session. Hope you found it useful. Feel free to come up to either of us and ask more questions. We'll be happy to do that. So yeah, thanks.